In this video series, we are going to look on about the operating systems. In that, the overview and the process management is going to be dealt with. So regarding the operating system, the three major operations are going with process management, memory management and storage management. So the process management is the major category where how the process is created, how the resources are allocated to the processes and how the process has been terminated. So in this video we are going to look on about the concept of the process. What are the stages of the process and how it is created. So the subtopics what we are going to deal here is the introduction to the process states, the introduction to the process control block and threads. So process means what? Basically, program and process are different. A program can be always called as a passive entity and the process will be always called as an active entity. Means that whenever the program is allocated for execution inside the CPU, it will be active and it is called as the process. So we are going to provide our job in terms of batches where it is going to divided into number of user programs. So these user programs are divided into number of processes and these processes are going to be executed. So a process can be called as a program in execution. So every process consists of a or every program to be in the correct way, every program will consist of a text section, a program counter to keep track of the current activities and the processor registers, and it consists of stack, data section, heap, etc. So the basic structure of every program provides with all these four concepts, and this is a diagram of that where the stack is going to load all the information of the data and heap data text will be aligned in between that. Now we'll move on to the various states of the process. The various states includes new state, running state, waiting, ready and terminated. Whenever a process is created, immediately it enters into new state. And when the process is assigned with the CPU, it is called as a running state. And when the process is waiting for the CPU, that means during the running stage, if it wants any IO operation to be carried out, then it will be put in the waiting state and it will be returned back to the running state. Whenever the process enters the queue for executing in the CPU, it is called as ready state. Finally, the process will be terminated after its execution is over. So that is called as terminated state. So this is the diagram of the process states. When the process is newly created, it is admitted into the ready queue where it enters into the ready state. From the ready state, it enters into running when the CPU is ready for executing that process. Suppose if the process needs any IO event or some other interrupt happen, it enters into the waiting state. After that completion, it enters back to ready. From ready, it enters into running state. Finally, if the process completes its execution, it is terminated. So all the information of the process are stored in the process control block where the first data given by the process state, it provides the current state of the process, either it is in running state, waiting state or in some other states. Then the program counter that stores the location of the instruction to which should be executed next. Then it consists of the CPU registers where it contains all the process centric registers and it is stored there. The memory limits and the list of open files, all those will provide the information about the memory allocated for that process and what are all the files opened for the that particular process execution. And this particular diagram shows how the CPU switches from one process to other process. Whenever a current process is in executing state, all other processes will be in the ready queue. and it stores the information into the PCB that it is in execute state and save its state. If any interrupt happens, the current state will be stored again back to the PCB and the executing process will enter into the waiting state, that is idle state. Meanwhile, the second process P1 will start executing by the CPU and that information will be loaded from the PCB and it starts executing. Once it is completed or again an interrupt happen, the state information of execution will be changed to interrupt or waiting and that information is stored in the PCB1. So it shows that every PCB consists of a particular process information. Thank you.